Okay, I'm glad. I think you just gave me a compliment, so thank you. Okay, here we go. I asked you, if you did not do this problem, that was your own choice. I will go through it quickly, but I'm not going to go over the entire problem because we're going to do another one right after this anyway. So here we go. Here are your answers. First off,
how did you get KOH to be in the reactor? Yeah, that's where I can be everything else, but like, as soon as oh no, this is in the reactor, I'm like, no, it's not, yeah, and try that.
okay, hold on. Yes? Oh, he's answering the question. Never mind. Sorry. You're fine.
That's me. All right. So it's 2 moles. So you need basically 2 moles for every 1 mole of PbNO3, right? And so that means you have to have twice as much as KOH of Pb. And so if it's 1.4 and the other one's 2, so KOH is 2 and Pb is 1. That means that if it's 1.4 moles and there's only 2 moles of KOH, there isn't enough KOH to fully complete, like, to get all PbNO3. So, like, never mind.
It's okay. No, I thought you did fine. This is how I do it. This is the mold right here, right? Thank you. No, we're good. Say that one more time. That worked on a problem we did yesterday. And I said, because it doesn't, because of the ratios. It's okay. So look, what I've been saying is it's 2 moles is 2 times bigger than 1.4. There is one coming up that's going to be, it's not harder, but you have to make sure you say things the right way. All right, here we go. So that's where that came. Limiting reactant was KOH. Precipitate, or my solid, was PbOH. All right. Over here, that meant the OH was in both, so it was 0 at the end, because it runs out and it's tied to the solid, so it's not in solution. That meant these 2 things were the spectator ions. All right, so they'll be easier to find later. Okay, the picket fence to find the grams was nice because it was 2 moles. All right, from the arrow pointed right here. It's been covered a ton. All right, what? We're going to do another one right after this. All right, so that 2 came from there. This 2 came from the coefficient. This is the mass of PbOH. The 2's just canceled out. It's 241. The total volume in this was nice because it was 500 milliliters plus 500 milliliters, which makes 1 liter. So the math was easy. Do you know where this 2.8 came from? Okay, some of you won't. Look right here. 2.8, this is your moles of NO3. Coming back to the top, your moles of PbNO3 was 1.4. But for every 1 PbNO3, there are 2 NO3s. So that is why the concentration is twice that value. There are 2 NO3s to every 1 PbNO3. Okay? So that is why this number is 2.8. Fine, don't move. I didn't want you to anyway. Hold on. All right. Now, you just divide that by the new volume, which is 1. That makes 2.8. Now, K, I'm going to do the same thing. I find its initial moles, and it stays constant. Since, I'm going to erase a ton of stuff here, because it's complicated. Since K, there's no subscript on K or OH, right? So whatever the concentration of this equals is the same for K and OH. So 0.5 times 4 was 2 moles. K will be 2 moles. H will be 2 moles. So I come down. That's where this 2 came from. The new volume is 1. I get 2. Okay. Now, the excess reactant, it's equal to my initial. Okay? The initial minus my used. The initial was 1.4. Oh. That came from this number right here. You okay with that? Now, we said this was my limiting reactant, correct? All right. So now, the used is determined by my limiting. There were 2 moles of limiting reactant available, right? Please look at this idea here. For every one of these used, how many of these did I use? 2. So, how many did I use? I used 1. If there are 2 available to 1 available, I use 2 to every 1, which means I use half as much as I had here. We'll do it again. We'll do it again. So that's a 1 divided by 1 equals 0.4. That is like a law that you would get away with. No. Let's do the next problem. When we get to that, we'll work through that process again. Okay. Just to know what it is. Okay. This question, and you'll notice, that video is not recording, but you can see that I am recording this screen. This is the same question off the test. All I do when I give this test is I'm going to change this number, probably that number, and that number. That's all I will do. Everything else will be exactly the same. Now, when I cut this, I obviously is a question G that says, what's the concentration of all ions? Yep. Okay. I'm going to pause this and see. It's okay. So, it says how many moles of each species are present in the reaction. So let's do it. Now, when it says this, it wants Ca, Cl, Ag, and acetate. Now, we haven't been doing it that way, but that's okay. We can do it now. So we have this we have to multiply, right? And that will give me the moles of CaCl2. When I take this number and times it by that, I get 0.125 moles CaCl2. Now I'm going to go ahead and distribute that. That means I have 0.125 moles of Ca plus 2. How many moles of Cl do I have, though? 0.250 moles Cl minus, because for every 0.125 I have 2 chlorines. So I have to double it. Okay. Oh, that's covered, so we won't undo that. All right, and then my silver nitrate is easier because there's no subscripts, right? So it's now 0.6 times 1. So I have 0.6 moles Ag plus and 0.6 moles C2H3O2 minus. Now, the way that the overall AP test is written, it asks you questions in steps, and the step will help you on the next one. It really is written to try and help you and guide you through what you should be doing. All right, what's the total volume of the solution? It's 0.85. It's this plus this. It's the two beakers, their volumes added together. All right, what is the limiting reactant, and justify your answer? Okay, so I'm going to rewrite these right here. I'll tell you. 0.125, that's CaCl2, correct? 0.6 is here. So the Tom Davidson way of doing this is asking your question, is 0.6 at least twice as big as 0.125? Yes, it is, which means that this is your limiting reactant. All right? The justification would be you need twice as much silver nitrate as you do calcium chloride. You have that amount, so the calcium chloride must be your limiting reactant. That sentence or paragraph or whatever makes sense. Yes, Diane? Yes. We're always finding the bigger coefficient. So it doesn't matter which one it is, it's just the bigger of the two. If the bigger of the two, the answer is no, then that is your limiting reactant. If the answer is yes, then it's the other thing that is your limiting reactant. All right. Okay so far? Okay, next up, what would the mass of the precipitate be? All right, we're just trying to find the grams of AgCl2. All right, so I just take my moles of calcium chloride. It's 0.125 moles CaCl2. And then for every 1 mole CaCl2, how much AgCl do I have? Okay, 2 moles of AgCl. Then what unit has to come down? 1 mole AgCl. The unit at the end always matches the unit at the end. I don't know, is that a 2? Did I really put a 2 right there? I wasn't supposed to. All right, it's just AgCl, and I hope, is that right from my memory? Okay, that's 143. When you type this out, I don't remember. What's that? 35.8. All right, how many had that answer right? Okay. All right, then part G, which I didn't cut, but I wrote down here. Oh, I have erased it. What was G asking you to do? All right, so the ions, first off, there's one that's 0. The Cl was both limiting, right here, and in the precipitate. So that's 0 molar, correct? Okay, this is kind of a pain to stand and write. Okay, so next, just erase this. The next thing would be the easier of the two things left, and that would be the spectator ions, right? I'm going to divide both of them by 0.85. Okay? And I just need to go find their initials. Now, that's the nice part of part C, is I already have those written out. So I need acetate. Okay? And calcium, just for writing purposes. I'll just put it right there. So the calcium was 0.125. So I wrote it right there. And then the acetate was 0.6. So I do both those. 0.125 divided by 0.85 was... What's that? 0.147. That was calcium, right? Okay. Then 0.6 divided by 0.85. What's that? Yes. No. Look at the screen. It's okay, Caitlin. I know why you think it's in. You double it if it's a subscript, but you do not double it if it is a coefficient. Okay, the coefficients are just balancing the whole thing out to make sure the number of atoms are equal on both sides. But the subscripts are giving you the ratio of atoms. So that's why they count in this process, but the coefficients don't. All right, that was 0.7. Is that what we just said, right? Okay, then the one that no one really likes. The excess is equal to my initial minus used over my new volume, right? My new volume is 0.85. The initial was what? 0.6. I got that from part C. We're finding silver, is that right, what this one is? Okay, so it was 0.6. Okay, now, I need everyone to look and try and follow the logic. You might need to watch this recording like 10 times over and over for this part to make sense. It's not that bad, but it's just not something we do all that often. Okay. So please remember, we are defining silver, right? But the amount of silver used is dependent upon my limiting reactant. Are we okay with that? All right, thank you. So please look. Every time I use one of my limiting reactant, how many of these will I use? 2. Let me repeat that. Every time I use one of my limiting reactant, how many of these do I use? 2. So now look, every time I use 0.125 of my limiting reactant, how much of the other thing do I use? 0.25. Because it's a 1 to 2 ratio. So no matter what I put here, I will double it, and it will be that every single time. Okay, so that means if I have 0.125 moles of limiting, I will use 0.25 moles of my excess because I use 2 to every 1. So this becomes minus 0.25, and I do some math, and I got what number? 0.411. Okay, I've never written it out like I wrote on Olivia's paper, but it seemed to make sense, didn't it? Okay, so if this helps you, it will help you. If it doesn't, then don't stress about it. But what we did, let's see if I can even explain it again, because I'd never really explained it this way. All right. What we are going to do is we're going to take our moles of limiting reactant. Because remember, it's the thing that determines what happens to everything else, right? So it's kind of your number generator is the moles of your limiting reactant. And then we multiply it by the ratio of your excess reactant and your limiting reactant. Now, these ratios are the coefficients. And that will always tell me the amount that I used. Okay? So I did that process. If we just put the numbers in, if I remember, this was 0.5 moles of limiting reactant, correct? Then I just take the ratio of excess over limiting. The coefficient of my excess was 2. The coefficient on my limiting was 1. And so that equals 0.25. And that is where this number comes from. Does that make sense? Raise your hands if that kind of helped that click. Okay, good. Thanks for sounding that out with me earlier. We can apply this same thing to the problem we just did. Oh, that's going to be ugly, but whatever. Come on. Let's copy that. There it is. I think my vision's finally getting not as good as it used to be. I've always had really good vision. Okay. This is a lot of work, probably for not much use, but whatever. Okay, so let's shrink this up right here. So in this problem, my moles of limiting reactant, oh, geez, Tom. The moles of limiting reactant, was KOH our limiting, correct? It was 2. Oh my, I'm going to say bad words any second. Half of you like are in my religious boundary, and you'll be like, oh my, this guy's such a jerk. All right, 2 moles is my limiting reactant. Coefficient in front of my excess reactant was a 1. In front of my limiting reactant was a 2. 2 times 1/2 equaled how much used? 1. And that's where that number came from. You all right with that? Okay. I've been saying this, sort of, but that's kind of a more written out way that might help quite a few of you to straighten that out. That's not what you were supposed to do. Well, that wasn't supposed to erase either. Whatever. Let's just, I can't undo it. Forget it. Are we ready for the next problem? Okay. This one, again, is just like the one on your test. Have I stressed that enough? It's just a test. Okay. Get out of here. Is it like 2 minutes? Okay. Do this one instead. Right here. Take a picture of this. I know it's hideous, but the reason you take a picture of it is because then at least you have like the problem, and then you have all the answers too. Now, it's tricky. The volume and the molarity I gave you is right here of each one. It's really small, but hopefully you can read it. Okay? Tomorrow, I will spend 10 minutes going over this problem. The rest of the hour tomorrow, I will be reviewing for the exam, which will be on Friday.
Yeah!
Yeah, thanks, Diane. Now, just one thing. Some kids think the test on Friday is extremely long, but that's because they take 40 minutes to do one of these problems. There is only one, and the intent is that that problem takes you around 10 minutes. If it takes you 40 minutes to do one problem, then the test is long. If it takes you 10 minutes to do it, then the test is about 40 minutes long.